All right, so we're going to talk about meteorology today. Meteorology is the study of weather. It's the study of the atmosphere and the conditions at any one place on Earth at that time. It's known as the weather. And that's what we're going to kind of talk about today. Um, the atmosphere is really important. Most life on Earth couldn't exist without an atmosphere. I mean, we have undersea life and things like that started down when life first got started, but we really need oxygen. Even fish need oxygen from the atmosphere to mix into the water so they can breathe. They don't breathe oxygen molecule. They don't break down the H2O molecule. They breathe like air molecules that are bubbled into the water is how they breathe. And their gills filter that out. They don't do a chemical reaction for it. So it's really, really important. It contains all the gases that we need for life. And of course, life on Earth is suitable to the gases here because if we weren't suitable to these gases, we wouldn't evolve. So, the importance of the atmosphere is that it helps keep the planet warm. There is a greenhouse effect. Um, if it didn't, the gases in the atmosphere didn't hold some of the heat in, this planet would be really, really cold. This would be an ice planet. So we need greenhouse gases to keep it a certain temperature. But if we have too much of the greenhouse gases, the temperatures start to rise, and that has really negative effects. And I'll be talking about that more as we go through um, this thing. It protects us from dangerous radiation. Our ozone layer protects us from ultraviolet rays, and that's repairing itself now, which is a really, really good sign. I'd love to talk about that a little bit. It also burns up things coming in from space, like rocks and meteors that come in. Most of them that come in get burned up. They're not big enough to make it to the ground or cause any damage. They burn up high in the atmosphere, in the mesosphere, when we talk about the layer. So it's really important. So it does all that. It protects us from cosmic rays. It absorbs a lot of cosmic rays before they get to the ground. So it really is integral to life. The composition of the atmosphere made up primarily of two gases, oxygen and nitrogen. Now, nitrogen is the most abundant of it. Nitrogen makes up about 79% of uh, the gases on the planet, or 78%, I'm sorry, not 79, 78% of the gases on the planet. And, close to 80%, and it's about 19% or 21% oxygen. So we have this 1% that's other gases. That's all the carbon dioxide, all the methane, every other gas makes up combined makes up 1%. So carbon dioxide is a very small amount, but that small amount traps enough heat so for life on the planet that we're used to. By dumping more carbon dioxide into the atmosphere, we're going to trap more heat. And it doesn't take a lot to do that because it makes up such a small percentage. So we'll go by that. So a lot of people think that oxygen is the main gas in the atmosphere, and it's not. And it's a good thing that it's not, because oxygen is a catalyst for fires. Fires would be so hard to put out once they got started. If there was like an 80% oxygen atmosphere, it would be horrible. We would be almost impossible to put out fires. So it's a good thing. The mix we have is really, really good, and it's suitable for what we're doing here. Um, Let me see. Water vapor is also kind of a gas that's in the atmosphere. We don't count that as a gas, but it's in there. It goes through the water cycle, and there's different amounts in different areas, and that's what makes up the clouds. Up at the poles, there's not a whole lot of water vapor in the air because the air can't hold it. And near the equator, there's a lot of water vapor. It's almost always humid down around there. Um, and then there's also particles that are trapped in the air that are dust particles and things like that. Pollution. There's natural forms of pollution like pollen and things like that. And then there's unnatural forms of pollution where we're burning fossil fuels or we're burning wood or things like that. We're just breaking things apart and the aerosols go into the air. So that's one of the things. So we have to, be careful about the atmosphere and take care of it. Now, I want to talk about the layers of the atmosphere, and that's kind of why I put this board up back here. Hopefully you can see it, and it's a lot like the one that you have in the PowerPoint. And I kind of want to explain it. When we talk about weather, that's the bottom layer, the troposphere. Almost all weather happens in the troposphere. Um, that's where the clouds are, that's where it rains and everything. And that's where most of the atmosphere is found as well. Um, 80% of the mass, of the weight of the atmosphere is in the troposphere. As you start to get up, the air gets thin. And if you've ever gone to mountain climbing or anything like that, you know that the air gets a little thinner. If you live in Denver, which is a mile above sea level, the air's thinner there. It's harder to breathe. So athletes, when they go into Denver, athletes that live in Denver and play in Denver are accustomed to that, and they're used to breathing the air that's thinner. Um, so they have an advantage for against teams that come into that area that aren't as accustomed to it. They don't process the oxygen as fast enough, and it leads to fatigue and things like that. So you get an advantage if you're the home team in Colorado. Um, After that, we have the stratosphere. Now, the stratosphere is where the ozone layer is, and that's important. I ought to backtrack a little bit. There is a question on the slides that says, how do we break the layers of the atmosphere up? And we don't do it by altitude. We can say at a certain altitude they start, but we do it by temperature, by changing temperature. If you notice in the troposphere, as you go higher in the atmosphere, the temperature is dropping. It's getting colder and colder and colder as you get up there. But once you hit the stratosphere, it turns around and starts getting warmer again. Why is it getting warmer? That's where the ozone layer is. The ozone layer absorbs ultraviolet radiation. As it's absorbing that radiation, it's warming those particles up. Okay, as it warms those particles up, they heat up. So that layer starts to get warmer again. Ozone is oxygen gas. Most oxygen gas is O2 that we breathe. Ozone is O3. There's an extra oxygen on there that's just the right size to absorb those radiations. And it's basically the sun creates ozone in the atmosphere. The strong rays break an O2 molecule apart, and oxygen's so reactive it'll just grab onto another O2 to make O3, but it's kind of fragile. It's not as stable. So gases like CFCs that were released that are in aerosols for hairspray and things like that, especially back in the 60s, 70s, and 80s, was really, really damaging. They've changed the formula so it's not as damaging now, and the ozone hole is repairing itself. But that thinning ozone allows more ultraviolet radiation to get through. But since it's repairing itself, this is where it absorbs that ultraviolet light. So it's heating up this area. So the first layer, the troposphere, it gets colder as you go up. But then once you hit the stratosphere, that's where the ozone layer is, and it starts to warm up. Now, when you get up to the mesosphere, the next layer, this is the coldest layer. This gets down to almost negative 60 to 70 degrees Celsius. It's negative less than a negative 100 degrees Fahrenheit. It's really, really cold. This layer of the atmosphere, because it's getting so thin, is just not enough to generate any heat. Now, as this is also the layer, even though it's the coldest, it's the layer that burns up meteors. Now, a lot of people say it's friction that burns up meteors. Oh, the friction of the air. That plays a very small role. It's the compression of gases. If you pump up a bicycle pump, if you notice, after you pump up a tire, you're pumping it up. If you grab it where the hose connects to the cylinder, that's going to be really hot. That's because as you compress a gas, you heat it up. So when a meteor is coming in at 15, 20,000 miles an hour, it is compressing the gas really fast. And as it's compressing that gas, it heats up and it burns up the meteors. And that same thing when spacecraft return from orbit and they're coming in. This is the layer as they go through. They're falling through it. They start to generate a lot of heat and they can burn up. And we had the space shuttle Columbia had a hole in the wing, and when it was coming through, it kind of ripped it apart and it burned up on reentry. It was a really sad day. But that is our mesosphere. Now the last layer, the thermosphere, this is the hottest layer, but let's talk about that. Each individual particle is hot if you measure the temperature of each particle, they would be very hot. But since they're so far apart, you would feel cold. You're practically in outer space when you're in the thermosphere. We don't know where the edge is, the space, because it's like lumpy and things like that with the atmosphere. So you're basically in space when you're up in this layer. There's so few particles, it would feel very, very cold, even though each individual particle was very hot, because this is what's absorbing the initial brunt of the sunlight as it comes in. You get the aurora borealis is where this part is where it happens. The magnetic field comes out of the Earth at the North and South poles, and they go in and they kind of form a bubble around the Earth. Well, when magnetic particles come from the sun, hit that magnetic field, it pushes it around the Earth. So the Earth's here, as it's coming thin, it pushes it around the Earth. Well, some of them get dragged down at the North and South pole. As they come in, those charged particles make the atmosphere light up. They react with the nitrogen and oxygen that's in the North and South pole, and they create the aurora borealis, the northern lights and the southern lights. Really beautiful. If you go up to Sweden or Iceland during solar maximum, you could see them, and it's definitely on my bucket list. It's something I've got to see. Haven't seen them yet, but I will get there. So they're the layers of the atmosphere, and this is the graph you want to look at. Temperature getting hotter. Here's about freezing point of water. Average temperature on Earth is just a little bit warmer than that. As you go higher, it gets colder. Hit the stratosphere, the ozone layer absorbing that solar radiation, gets warmer again. Then you go into the mesosphere where it gets really cold. Asteroids or meteors burn up in there. And then you get to the thermosphere, which is technically the hottest temperature for the particles, but they're very, very far apart, and you're not going to get overheated in that kind of way. So that's your layers of the atmosphere. Now, I want to get into pressure and talk about pressure, but most of the stuff that I do with pressure is in school, and I'm trying to work out some things at home so I can do some demonstrations here for you guys and all that stuff. So I would like to do pressure next, but I'm probably going to have to rework something and go into something else first and then go into pressure a little later in the week. So thanks for watching, and I'll see you guys later.